Good morning, students. So now continuing your Fourier series, lecture 3. Today we are seeing the topic definition of even and odd functions and their examples. Okay. So even and odd functions. A function f of x is said to be even if f of minus x equal to f of x. That means your function f of x equal to suppose x. So you are replacing every x place, x square, x plus you are replacing minus x. So minus x whole square equal to, once again you are getting x square. Okay. So that means f of minus x equal to f of x. So you are in your function, every x place you are replacing minus x. So once again you are getting a same function. Okay. That is f of minus x equal to f of x, and odd. Even means we are getting if f of minus x equal to f of x, on or if f of minus x equal to minus x. Suppose you are given function value f of x equal to x or x cube. So you are replacing every x place minus x. Once again we are getting minus x. So that means your function is you are changing in negative. F of minus x equal to minus f of x you are getting. That function is odd. F of minus x equal to we are getting f of x once again. That is an even function. Okay. For example, x square, x power 4 plus x square plus 1. So just you are every x place you are replacing minus x. Minus x whole square is once again you are getting x square. Minus x whole power 4. The power is even, we are getting always positive. Minus x whole square. So your square minus x squared is x square. So this is the even functions of example. So for e power x plus e power minus x also. And x cube. So x place in your given function replacing minus x, you are getting minus f of x. So x cube, x, sin x, cosecant x are odd functions. Okay. In even function, your sin. In even function, cos means in your even function. Okay. One note, product of, already I told this one in my previous class, product of two even or two odd function will be an even function. Now we are talking about the functions. Okay. So next note, product of even function and odd function will be odd. So both the functions are odd and both the functions are even. The product we are getting even. One function is even, other one is odd, we are getting odd function. Product is odd function. Okay. As one more note, integral a to minus a to a f of x dx equals 0, that f of x is an odd function. So in your integral, so this also we are substituting in previous lecture also. So minus a to a f of x dx equals 0, your function is odd. So we are, suppose your function is even, as possible you write 2 into integral 0 to a f of x dx. Okay. The series for even and odd functions, we know that a function f of x defined in minus pi comma pi can be represented by the Fourier series f of x, as it is here formula f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n x plus summation n equal to 1 to infinity b s sin nx. Okay. So we know the values of a naught equal to 1 by pi integral minus pi to pi f of x dx, a n equal to 1 by pi integral minus pi to pi f of x cos nx dx, and b n equal to integral 1 minus pi to pi f of x sin nx dx. So listen, as it is the equation here, particularly your given function is even or odd. Okay, you are substituting here. Suppose in terms of your, product of two even, two odd functions as an even function, product of even and odd, we are getting odd function. Okay, the concept you are using here, So now we are substituting f of x. Suppose here f of x is an odd function. So odd cos is an even. It's valid. It is odd function. You are multiplying odd into even, your value odd. So you know the integral minus pi to pi, the function is odd, your solution is 0. Okay. Suppose cos nx is even function. Your given function is suppose cos x or x squared, any even function. Even into even is even. The time as possible to 2 times of integral 0 to pi in your function into dx. Okay. In your Bn also as the same procedure, depend on f of x. Is sin nx is an odd, f of x is an suppose odd into odd is odd. Suppose it is an even into odd, its value is 0. Okay. So the case 1, case 2, f of x is even, f of x is an odd function. So first we are seeing the odd function case and even function. F of x is a even function. A naught is as it is, we are writing here 2 times. So why? It is particularly, it must here f of x value is even. A naught equal to 1 by pi integral minus pi to pi f of x dx equal to 2 by pi integral 0 to pi f of x dx. Since cos nx is an even function, f of x we are taking or we are assuming f of x is an even. So product of even is once again even. So then f of x cos nx is also even function. So it is valid. It is possible to write 2 times of 0 to pi into your function. Then only we are writing an equal to 1 by pi integral minus pi to pi f of x cos nx dx. Hence, we are writing this integral is 2 times. So 2 by pi integral 0 to pi f of x cos nx dx. Okay. As it is, we are writing the Bn value. Bn equal to 1 by pi integral minus pi to pi f of x sin nx dx equal to 0. Why we are writing this value is 0? Sin nx is an odd function. We are assuming f of x is an even. So already I told even into odd is an odd. So your integral minus pi to pi odd function is value is always 0. Okay. Otherwise you check it, write down in your any function, suppose x cube, integral x cube, your minus pi to pi, your limit, upper limit minus lower limit, you are substituting, your answer is obviously 0. Okay, why we are using these formulas? Sir, for I give one some example. We know the 2 tens are 10, okay, or 4 5s are 20. Okay, so you know the multiplication table, you are directly writing. Otherwise, so you know the multiplication means as a repeated additions. Okay, so you are writing 2 plus 2 plus 2 plus 10 times is 20. It's a long procedure. Obviously, you know 2 times are 20. Directly we are applying. Okay, so it is the concept for here. You know the 2 odd function. It is 0. It's an even function. You are writing 2 times of integral 0 to pi f of x dx. Okay. That is the reason we are using this concept here. So you are general applying for integration, applying limits after your solution as same it is. So already it is derived values. How do you are know the 2 times are 20? As same like that here also. Okay. Suppose you forget, you are applying the procedure, also you get the same solution. So now f of x equal to, so here your total 0. So you are writing a function f of x equal is even in interval minus pi comma pi. Its Fourier series expansion contains only cosine terms. Why? In a sine term into even is 0. F of x equal to a naught by 2 plus summation n equal to 1 to infinity an cosine x. So clearly you know your given function is even function. Just you are finding a naught an, substituting a formula, get the solution. No need to find the Bn value. Okay. an. So here only we are finding a naught an values. An equal to 2 by pi integral 0 to pi f of x cos nx dx. N equal to 0, 1, 2. Next case 2. When f of x is an odd function n minus pi comma pi. So now your given function f of x is odd. So a naught equal to 1 by pi integral minus pi to pi f of x dx equal to 0 while odd in your interval minus pi to pi. So it is values a naught 0. Next we are finding an value. Here f of x is an odd, cos nx is an even function. Your product of odd and even is once again odd. Then only this value also 0 an also. Next we are go for the bn value finding. So in your bn sin nx is an odd function and you are assuming your f of x is odd. Product of odd functions, two functions is an even. So it is valid. We are writing 2 times of integral 0 to pi a function dx. Okay. So then only it's valid for bn only. So bn we are writing 1 by pi integral minus pi to pi f of x sin nx dx equal to 2 by pi integral 0 to pi f of x sin nx dx. Therefore, f of x equal to summation n equal to 1 to infinity bn sin nx. So clearly you know your given function is an odd function. Only in your Fourier series you are calculating f of x equal to summation n equal to 1 to infinity bn sin nx. So your a naught and both the values are zeros. So it's a very simple. So you are find out your given function is an odd function. Your Fourier series expansion f of x equal to summation n equal to 1 to infinity bn sin nx. Then bn equal to 1 by 2 by pi 2 times 2 by pi integral 0 to pi f of x sin nx dx. Okay, it's clear. So now we are seeing the examples, even odd functions of Fourier expansion. So listen your question. Expand the function f of x equal to x squared as Fourier series in minus pi comma pi. Hence deduce that 1 by 1 squared minus 1 by 2 squared plus 1 by 4 squared and so on equal to pi squared by 12. Okay, this is your function. So listen, your f of x equal to x squared, x power 2. So here f of minus x equal to f of x. Suppose in x place you are replacing minus x. Minus x squared equal to once again you are getting x squared. Okay. So then it's clearly we know it is an even function. So what is the Fourier expansion of even function? F of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx. Here we are finding only a naught a n. Suppose it is an odd function, your Fourier expansion is f of x equal to summation n equal to 1 to infinity bn sin nx. Only we find the bn value. It's enough. Okay. So now your given function is even function. That function is x squared in our interval minus pi comma pi. Okay. So since in your solution f of minus x in your given function x plus replacing minus x squared equal to x equal to f of x. Hence it is Fourier series expansion. The sign terms are absent. You know why? Sin into is an odd, your function is even, your product of odd into even equal to odd, then only your integral minus pi to pi f of x dx odd function equal to 0. So we are writing the formula f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx. Here only we are finding a naught and a n value, substitute in this equation. We get the solution. Where a naught equal to, you know the formula, 2 by pi is an even function. In your interval how to write 2 times of 0 to pi. Minus pi to pi is 2 times of 0 to pi. 2 by pi integral 0 to pi x squared dx equal to 2 by pi. Here integration of x power n dx equal to x power n plus 1 by n plus 1 plus 3. Okay. So So now here integration of x squared is x cubed by 3. We are substituting upper limit minus lower limit. We get the value is 2 pi squared by 3. Next we are finding the value of an. We know the formula for an equal to 2 by pi integral 0 to pi f of x cos nx dx. So in your integral is as even, then only you are 2 times of 0 to pi. Minus pi to pi is we are replacing 2 times of 0 to pi. So now substituting here f of x is x squared. Now we are applying the here Bernoulli's formula. Integral u dv equal to uv minus u dash v1 plus u double dash v2 plus and so on etc. Alternative sign in your formulas. So what is u? Your highlight method, you are take to u and dv values. U equal to algebraic function x squared, dv equal to cos nx. So listen, first derivative of x squared is 2x. Second derivative of x squared is 2. Third derivative 0. So up to we are finding u dash, u double dash. Table dash onwards we are getting zeros. So then only we need v. We find v, v1, v2. It's enough. Okay. So now we are applying u, v. U is x squared. V. Integration of v is v. Integration of cos nx is sin nx by n minus differentiation of x squared 2x. Integration of sin nx by n value is integration of sin nx is minus cos nx by n. So already 1n. So then only we are getting minus cos nx by x squared plus 2. Differentiation of 2x is 2. Integration of cos nx is sin nx, already that's negative, by n, already 1n squared into n is n cube. So your value is minus sin nx by n cube. Next step, you are substituting upper limit minus lower limit. We know the values of sin nx. Value is minus 1 whole power n. Sorry, cos nx equal to minus 1 whole power n. Sin nx value equal to 0. Sin 0 is 0. Cos 0 is 1 always. Listen, once again I tell you. Cos n pi equal to minus 1 whole power n. Sin n pi equal to 0. Sin 0, 0. Cos 0, 1. So now we are substituting upper limit minus lower limit. We get the solution 4 cos n pi by n squared equal to, you know the value of cos n pi equal to 4 by n squared into minus 1 whole power n. So now this is substituting the values of a naught and an from in your equation 1. That is x squared equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx. Place we are replacing a naught value and an. So now we are substituting a naught an values. We get x squared equal to 5 squared by 3 plus summation n equal to 1 to infinity 4 by n squared into minus 1 whole power n cos nx. So listen, we are substituting n equal to 1, 2, 3 and so on values. Here summation, x plus that summation values, x squared by 3 minus 4 is a constant. So here substituting n is 1, we get cos x minus by n squared is 1 squared is 1 minus cos n is 2, cos 2x by 2 square, n is 3 plus cos 3x by 3 square minus cos n is 4, cos n 4x by 4 square plus and so on. So this is your solution of your Fourier series. In your question, to deduce some values, then only you are substituting x values. Put x equal to 0 in your previous equation. We get x LHS side x squared is totally 0 equal to 5 squared by 3 minus 4. 1 minus cos 0. Cos 0 is 1. Okay, cos 2 into 0 is cos 0. You know cos 0 value is always 1. Then only you are getting this expression 1 minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus and so on. So this 5 squared by 3 take to the opposite side, we are getting this is negative in your or LHS side also negative 4 into this 4 is also one side take to product near opposite side go to opposite side. So 3 4 so 12. So we are getting the solution pi square by 12 equal to 1 minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus and so on. This is your required solution of your given question. Okay. Now see the next example. Find the Fourier series to represent the function f of x equal to mod sin x. Here limits minus pi less than x pi. Okay. So here is an your given function sin mod of sin x. Mod of sin x means you know it is an odd or even function. So modulus of sin is even function. Only sin means is an odd. Why here after modulus your value is positive? We know already. You are taking any value of minus 1. Modulus of minus 1 is positive 1. Modulus of minus sin x is positive sin x. So here observe that modulus is very important. Suppose generally a sin x means if you are taking it's a odd, but here even why you are getting f of minus x equal to f of x. It's modulus value. You observe that modulus is very important here. So now since mod of sin x is even function, so it is an even function, you know bn value is 0. Why? Bn equal to 1 by pi integral minus pi to pi f of x sin nx dx. Here odd into even function. Sin nx is an odd. Here mod of sin x is even. Then only bn value is 0. How to express your Fourier series for even function? F of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx dx. This is your equation 1. Okay. So now we are finding a naught and a n values. We know the formula for a naught equal to summation, a naught equal to 1 by pi integral minus pi to pi mod of x dx. So now it is an mod of sin x is an even function. Then only we are writing two types of integral 0 to pi. So next step we are writing 2 by pi integral 0 to pi sin x dx. We know the formula for integration of sin x nx is minus cos nx by n. So here n is 1. Then only we are writing 2 by pi minus cos x, here limit 0 to pi. Now applying upper limit minus lower limit here. Your upper limit is pi, lower limit is 0. Cos pi, you know, cos pi is minus 1. Cos 180 degree. Cos 0 is 1. So here minus 1. It is negative, you are taking to the opposite side previously. Its constant is minus 2 by pi. Cos pi is minus 1 minus cos 0 1. So now minus 1 is minus 2 into minus 2 you are multiplying getting 4. 4 by pi is your a naught value. Next we are finding an. We know the formula an equals 1 by pi integral minus pi to pi f of x cos nx dx. A given function f of x is an even function. Mod of sin x is even. Then only we are reading two times of your integral 2 by pi integral 0 to pi sin x cos nx dx. So next step we are writing, you know the sin a cos b formula. Sin a plus b plus sin a minus b. So now we are applying the formula. A value is 1, b value is, a value is 1, b value is n. So then only we are writing 1 by pi into 0 to pi sin a cos b sin a plus b 1 plus n into x plus sin a minus b 1 minus n into x into dx. Now we are applying the integration. We know the formula for integral sin nx is minus cos nx by n. Integration of sin nx is both the terms are the same formula. Cos nx by n. What is n terms? This term 1 plus n by 1 plus n. Here, next term cos 1 minus n by n minus 1. N plus you are replacing your formula 1 minus n. So your limit is 0 to 5. So you are always n equal to 1 to 3 and so on. Now listen, you are substituting here n equal to 1 minus 1 by pi cos 1 plus n x pi 1 plus n. You are substituting the upper limit is pi plus cos 1 minus n x by 1 minus n minus lower limit is 0. First cos 0 into 1 plus n is 0. 1 plus n is 0, cos 0 is 1. 1 by 1 plus n square minus here 1 minus n into x value is 0. So the cos 0 is 1. Okay. So now we know the value of cos n pi. Cos n pi is minus 1 whole power n. So here listen, cos 1 pi. Your value is minus 1 whole power n minus 1 into minus 1. Why? It's a cos pi value is n minus 1. Cos n pi is minus 1 whole power n minus 1. So you club to these two terms in your denominator. Take the LCM values. Club the terms in your LCM. Denominator n plus 1, n minus 1 terms. So now you are simplifying this step. You get minus 1 by pi into minus 1 whole power n minus 1 into 1 by n plus 1 plus 1 by n minus 1 minus of 1 by n plus 1 plus 1 by n plus 1. So next step you are simplifying once again. We get minus 1 by pi minus 1 whole power n plus 1 n minus 1 by 1 minus n square minus 2 by 1 minus n square. So if the 2 is a common factor, we take to the 2 by pi n square minus 1 into minus 1 whole power n minus 1 minus 1. So now express this one. We are substituting the values. We are writing minus 2 pi. So simplifying this step, minus 2. You take the one negative in outside, that is your minus 1 is writing plus 1. So here plus here 1 minus 1 into whole power n minus 1 into minus 1 whole power 1 is 1 minus 1 cancel. We are writing minus 1 whole power n. So listen, depend upon n values odd and even, this value is expressed in your an. So an equal to 0 when your n value is odd. N is even, your value is minus 4 by pi n square minus 1 if n is even. Okay, why you are getting odd is 0? Suppose n is here 1 plus minus 1 whole power n. So n is suppose 1, 1 minus 1 is 0. Suppose n is 3, minus 1 whole power 3 is minus 1. 1 minus 1 is 0. Then only every n is odd, your solution is 0. An. Only value for n is even. So for n equal to 1, we get a1 equal to 2 by pi integral 0 to pi sin x cos x dx. So here 1 by pi sin theta cos theta equal to sin 2 theta. 2 sin theta cos theta equal to sin 2 theta we know. So this 2. Then only you are writing sin 2x dx. So integration of sin nx is minus cos nx by n with here 2. Then only you are writing 1 by pi minus cos 2x by 2. Your limit 0 to pi. So now applying upper limit minus lower limit, cos n pi minus cos 0 is 1. So now here listen, cos n pi 2 pi. Cos 2 pi is 1. Cos pi is minus 1. Cos 2 pi is 1. Cos 3 pi is minus 1. Alternate is 9. We are getting cos 2 pi value is 1. 1 minus 1 equals 0. Totally your a1 value is 0. So now you are substituting a0, a1 and an in equation 1. We get mod of sin x equal to a0 by 2 value is 2 by pi plus summation n equal to that n is even only exist values, odd is you are getting 0 for an. Generally you are writing your summation is n equal to 2, 4, 6 and so on to infinity minus 4 by pi into n square minus 1 into cos nx. So now we are simplifying next step. You are substituting. So here take the minus 4 by pi is a constant. So you are writing next step 2 by pi minus 4 by pi summation n equal to 1 to infinity cos 2n x by 4n square minus 1. Replace by n by 2n. Why you are replacing n plus 2n? Here n is only valid for your even, odd is 0. Then only you are writing cos 2n x. That time as writing n equal to 1 to infinity. Now you are substituting n value is 1 in that n place cos 2x. n is 3, 2. So n is 2 means 2 into 2, 4. n is 3, 3 into 2, 6. Here numbers. These are not your functions. We are talking here numbers. So then only we are possible 2n. 2 into multiplying 1, 2, 3 any values. We are once again getting even. Then only you are writing 2n next year. Okay. It's clear. So now writing for the next step. Equal to 2 by pi minus 4 by pi summation n equal to 1 to infinity cos 2n x by 4n. N square minus 1 only, not 4. So here substituting now n equal to 1, 2, 3 etc. We get the solution sin x mod of sin x equal to 2 by pi minus 4 by pi cos 2x by 3. That is n square minus 1 plus cos 4x by 15 plus and so on. So this is your required solution of your given function. Okay. So thank you students. Next class I will explain in your next method of n series. Thank you.